Okay, in this lecture we're gonna go ahead and do something that is called trig integrals. So we're gonna start by looking at the integral of sine to the fifth power times cosine to the third power. We can find the answer to this integral by doing the following. We're going to save a cosine. So we got the original sine to the fifth power, and then we're gonna save a cosine. So this is gonna be cosine squared, cosine of x dx. That's the cosine that we saved from cosine cubed. Then this is going to be equals to sine to the fifth power, and this cosine squared is going to be 1 minus sine squared, and this is the cosine that we saved. So as you can see, everything is in terms of sine except for the cosine that we saved. So we're gonna let u equals sine of x, then du is cosine of x dx. By doing all of that, this whole integral becomes u to the fifth power times 1 minus u squared du, and then multiplying we get u to the fifth power minus u to the seventh power du. So integrating, we get u to the sixth power divided by 6 minus u to the eighth power divided by 8 plus c. Substituting cosine back, we get cosine to the sixth power divided by 6 minus cosine to the eighth power divided by 8 plus c. Alright, this problem can be done in another way, and I'm going to show it to you in the next page. So again, we have sine to the fifth power, cosine cubed, and this time instead of saving a cosine, we're going to save a sine. So this is equals to sine to the fourth power x, cosine cubed x, and this is the sine that we save. By saving that sine and taking this sine to the fourth power, we can write the sine to the fourth power as 1 minus cosine square x squared times cosine square x, and then sine of x dx. So the idea here is to convert everything in terms of cosine, and then we're gonna let u equals to cosine, then du will be minus sine x dx. And by putting all this, we get minus 1 minus u squared times u squared du. The minus is because du is minus sine of x dx. Multiplying this out, we get negative 1 minus 2 u squared plus u to the 4th power times u. Oh, this is what's cosine q, so cosine q, so u cube, so u cube, du, like that. And this is the integral. So then this will be the integral of u cubed minus 2u squared, u to the fifth power, so u, and then plus u to the seventh power, du. Taking the negative sign into account, we get the integral of 2u to the fifth power minus u cubed minus u to the seventh power, du. And then integrating this, we get let's see, where did I get that 2 from? That 2 should not be here, so let me go ahead and erase it. Blah blah blah. This is just u to the I'm gonna go ahead and erase out of these and start all over, so we get equals to, all I'm doing here is bringing that sign. Oh yeah, so this is anyway, I'm just gonna go ahead and say this is I don't know, u, so the minus blah blah blah, the derivative of cosine is minus sine of x dx. Because of the minus sign, it looks like, yeah, we're gonna have the integral of 2 u to the fifth power minus u cubed minus u to the seventh power du, and then we integrate that, so we get 2 u to the sixth power divided by 6 minus u to the fourth power divided by 4 minus u to the eighth power divided by 8 plus c, and then you just plug in cosine of x, so we get cosine to the sixth power divided by 3 minus cosine to the fourth power divided by 4 minus cosine to the eighth power divided by 8 plus c. So it looks like you get two different answers depending on whether you use the first method or the second method, but the two answers are equivalent. It's just that in the first method we saved the cosine of x and we wrote everything in terms of sine, and in the second method we saved the cosine and we wrote we saved the sine and then we wrote everything in terms of cosine. Anyway, now what if you have the both of the integrals have like even powers? So let's say, for example, you have something like sine square x cosine square x dx. In that case, you would have to use half angle identities. So you would have to use, for example, something like, I don't know, I'm just gonna do something easier. So let's say you have this sine square dx You just write that sine square into 1/2 times 1 minus cosine of 2x dx. You can bring the 1/2 out, and then you integrate 1 minus cosine of 2x like this dx. So this is like using a half angle identity, and then you get 1/2, and then x minus cosine of x. When you integrate that, you get sine of 2x divided by 2 plus c. So we get 1/2 x minus 1/4 sine of 2x plus c. So basically, when you have even powers on both sine and cosine, you use half angle identities. I just did this single one because I can only do like 15 minutes on my lessons, otherwise it becomes very complicated to upload it on YouTube. But anyway, there it is. Thank you very much. This is called a lecture on trig integrals.